now that we've figured out everything that we can about theta, all its different trig values, let's see what we can learn about 2 theta. Even though I don't know the exact degrees for 2 theta, we can still figure out what sine of 2 theta is and cosine of 2 theta is and all that sort of stuff and by using the formulas. So the formula for sine of 2 theta, let's see here, that is this guy. Sine of 2 theta is 2 sine of theta cosine of theta. So let me go down, write that in. Sine of 2 theta is equal to 2 times sine of theta's value times cosine of theta's value. And I know those because we figured those out earlier. The sine of theta wasn't given to us, but we calculated that was -4/5. And the cosine of theta was what the original given was, and so we can put in -3/5 here. And to answer this problem, just multiply that out. It's helpful to write the 2 as a fraction as well, 2 over 1. And the tops multiply and the bottoms multiply. And 2 times 4 is 8, times 3 again is 24. The negatives times the negative is a positive, so that's 24 on top. And on the bottom, 1 times 5 is 25. And so the sine of 2 theta is 24/25. And I didn't really think about whether this answer is positive or negative. The formula, just plugging in numbers seems to come out to be a positive number. Let's look a second at what quadrant 2 theta is in and see if that makes sense. Should it have been a positive? It should have. I'm confident of that. But let's see that that's consistent with where theta ends up. Here's a fairly common trick. If you know what range of degrees theta is in, you can take that and double everything, and that will give you the range of degrees that 2 theta is in. And so if I double this entire inequality, I've got 360 degrees is less than 2 theta. And 270 doubled is 540, which means that 2 theta is somewhere between, here's 360 degrees, somewhere between 360 and 540, which puts it somewhere in either quadrant 1 or quadrant 2. I don't know for sure which that is yet, but in either of these quadrants, sines are above the y-axis, and so that would definitely make sine values positive. So let me fill in this quadrant information. I know it for sure is in either quadrant 1 or quadrant 2, and sines are definitely positive. And again, the formula gave me that. In general, the double angle formulas will correctly tell you whether it should be positive or negative. Let's figure out what the cosine of 2 theta is. And if we can figure out what the cosine value is, whether that's positive or negative, that'll actually allow us to figure out whether our angle is in quadrant 1 or in quadrant 2. Which would be very useful. So, in order to answer that, let's look up cosine of 2 theta formulas, and there's actually 3 different ones that we could choose from. Any of those are okay. They're all going to give us the exact same thing. I'm going to purposefully choose the cosine version of this, only because our given was the cosine of theta, and this is, I think, generally good practice to not introduce any more possible errors. Maybe we messed up calculating sine, and so if we can calculate what we need from the given and not arbitrary steps in between, that can be helpful. So let me write that formula down. The cosine of 2 theta is 2 times the cosine of theta minus 1. And so cosine of theta's original value, that was the -3/5. And I can calculate what this is. Ooh, close. Almost messed up. This is cosine squared. Whew. Glad I caught that. All right. -3/5 times -3/5 is positive 9/25. I still need to multiply that by 2, and then I'll have to subtract a 1 from that. So that's 18/25 minus 1 as a common denominator. That would be minus 25/25. And 18/25 minus 25/25 is negative 7/25. And so that's our answer. We can fill that in. Negative 7/25. And knowing now that the cosine value of 2 theta is a negative number, cosines are the horizontal part of an angle. And so negative cosines means we have to be to the left of the y-axis, which puts us in either quadrant 2 or quadrant 3. And combining that with our sine information, that has to be 2 theta has to be in quadrant 1 or 2, means that we have to be a quadrant 2 angle. And knowing that we're quadrant 2 actually allows us to figure out the sines of everything else. Tangent in quadrant 2 has to be a negative value because slopes are negative. Cosecants are reciprocals of sines, so those would be positive. Secants are the reciprocals of cosines, so those would be negative because our cosine was negative. Tangent's negative again, or cotangent's negative again because tangent was. And I can fill in the cosecant and the secant values, even though I don't have a secant of 2 theta formula, because I just figured out what cosine of 2 theta is. I can reciprocate that. That's 25/7. And cosecant, the reciprocal of sine, and so I could fill that in, 25/4. 24ths, that is. And the tangent values we can find in 2 different ways. We could pull out the tangent of 2 theta formula and calculate it. However, at this point, the fastest thing to do is probably just to divide sine and cosine by each other like we did last time. When we divide 24/25 by 7/25, the 25ths cancel out. So we have 24/7, and positive and negative wise, the value is going to be negative because positive divided by negative is negative, and that's consistent with tangents being negative in quadrant 2. So 24/7 negative, that's the tangent value, and we can reciprocate that. Negative 7/24 is the cotangent value. So there's all the different values for 2 theta. Usually in a problem you're not asked to find all 6 of these because that takes a lot of time. Usually you're asked to find 1. So they'll give you cosine of theta and ask you to find what tangent of 2 theta is maybe. It's a relatively involved problem because you have to find a handful of different things before you can actually calculate what you're interested in. One last thing I want to point out before we figure out what the half angle values are for this problem is the numbers, the numerators and denominators in this problem were 7 and 24 and a 25. And I just want to point out that those are another Pythagorean triple, and they have to be sines, cosines, tangents. They can all be referred to a right triangle, and so they're always going to follow the Pythagorean theorem that 7 squared plus 24 squared equals 25 squared. And again, if you recognize 7, 24, 25 as a triple, if you've seen that before, you can often take advantage of that in this problem to speed things along or to be confident that things are right. A common mistake is to maybe just have the 18 25ths, and if you look at 18, 24, 25, that's not a Pythagorean triple, so that should be a red flag that something's not right, to look more carefully and see if you find a mistake.